Today we're going to talk about section 2.2 subsets. Okay? What you will learn quickly shows the objectives of this section. So basically we're going to talk about concepts of subsets and what is a proper subset, and also determine the number of subsets and the proper subsets of a given set. Okay, so what is a subset? A subset is just first of all, is set A is a subset of set B, is denoted by the symbol A. Notice the bottom line indicates A may be equal to B. Okay, so by definition, if A is a subset of set B, then all elements of set A are also elements of set B. Okay, or every element A is a subset of B if, and sometimes we will say if and only if every element of A is also an element of B. Okay? So if you have this symbol, just means that set A is not a subset of set B. Now, how do we show a set A is not a subset of set B? Well, what you can do is that you can find at least one element of set A that is not an element of set B. So to show A is not a subset of B, need to find there exists A in A, but A is not in B. Okay, later I will talk about examples. So let's see how we determine whether set A is a subset of set B. Let's say set A, set B, and here what you can do is you check the definition if every element of set A is also in B, right? So here we can check. Let's see, in set A you have three elements: boat, train, and plane. All right. So you want to check is boat in B? Well, yes, right. Is train in the set B? Yes. Is the plane in the set B? Yes. So A is a subset of B. Okay. So what is a proper subset? Typically, we would denote a proper subset by this notation. Notice, note, it is not like less than equal to, okay? But here we don't use less than because you talk about two sets. So set A is a subset or a proper subset of B if two conditions. Okay, one, set A is a subset of set B. Two, A not equal to B, which means actually there exists B in B, an element in B, such that B is not in A. Okay, so again, I will talk about examples. So let's determine whether set A is a proper subset of set B. Well, let's see. Pretty easy that to decide jazz is in jazz in A is also in B. Pop is also in B. Hip is also in B, and hop also in hip hop. Actually, hop. Um, um, so hip hop is in so let me check that. So hip hop is in hip hop. So number one, we check two conditions. A is set A is a subset of set B. Check, right? It is. Number two is set A equal to B. Well, set A obviously is not equal to B. Check. So because, for example, rap is in B, but rap is not in A, right? So therefore, A is a subset, is a proper subset of set B. Let's say, again, this example, A equal to A, B, C, D, B equal to A, C, B, D, is a proper subset of set B. Or notice that in this case, set A actually equals to set B. You can look at this and notice order doesn't matter. So order of elements does not matter. Or because set A equals set B, so therefore set A is not a proper subset of set B because to be a proper subset, A cannot be equal to B. Okay, so number of distinct subsets. So giving a set A, how many subsets there are there in set A? Well, assuming set A is finite, provided A is finite, then mathematically we can show that there are actually exactly 2 raised to the nth power number of subsets in set A. Okay. Well, and then obviously that the number of distinct proper subsets is just the total number of subsets minus 1. 1 because we need to remove A from the sub from the collection of let me see, kind of switch to collection of remove A from the collection of subsets. Okay. So the total number of distinct proper subsets of a given set A is 2 raised to n minus 1. Okay, so let's look at an example. It will become clear. Okay, so let's determine the number of distinct subsets for the given set SLED. Notice the set contains 4 elements. Okay, so the solution actually is very simple. Using the formula, the total number of distinct subset is 2 raised to the 4, which is 16. And why is that, right? So let's list all the distinct subsets for this set. Okay, notice again it has this set has 4 elements. So what you can do is notice that the very first subset is just the set itself. So set itself, not a proper. It's not a proper subset, but it's a subset. And also notice that the last one is just a empty set or null set. Okay, null set is always a subset. So so here basically what we do is we list all. Let's denote this set by A. So I'm gonna change to that and remove that. So we first list let's see, the set itself. Set itself. A. So in general, any set is a subset of itself. Okay? And then we list the empty set. Empty set, which is the null set. Okay, and then we list all subsets of 3 elements and all subsets of 2 elements, and then, or it should be 4, 5, and all subsets of 1 element. Okay, so that's how you find all the subsets. So all the subsets of 3 elements, see SLED, so you just list it SLE. You can change, keep the first 2 SLD, right? And then take the last 3 LED. I believe that's all you have. And then all subsets of 2 elements as L, S, E, S, D. You keep the first element unchanged. Okay, and then you change S to LE, right? So LE, and then let me write here LD, and then D, ED, right? Change that to E, D. Okay, and all sorts of 1 element, that's easy. So it's just S, L, E, and D. Right, so that's how you find all the distinct subsets. That's it.